Assalamualaikum warahmatullahi wabarakatuh, and a very good day. My name is Nurul Hani binti Nur Asmadi, and my metric numbers is 23345133920. Today I'm going to present my research proposal with the title of Investigating Interfacial Interactions and Water Absorption in Esterified Crystalline Nanocellulose Reinforced Polylactic Acid Nanocomposites. So this is what I will go through during my presentation, which include introduction, problem statement, objective, literature review, methodology, and result discussion. So for introduction, recently extensive research is being conducted to develop increasingly sustainable replacement for prevalent plastic materials widely used in different areas such as packaging, healthcare, and transportation. And packaging has garnered significant attention because it ranks as the top contributor to global plastic waste. This is primarily attributable to the throw-away disposable nature of plastic packaging, which is often discarded after a single use. So consequently, environmentally friendly polymers have developed as a possible solution to solve this problem. Biodegradable polymers such as polylactic acid (PLA) have attracted substantial interest because of their exceptional strength and modulus qualities, establishing them as a focus point in this sector. However, the slow crystallization kinetics of PLA eventually lead to restricted ductility and decrease the thermal stability. And thus, the use of nano-sized fillers to generate nanocomposite have been one of the methods that stand out to solve this issue. So, cellulose nanocrystals is among the various nanofillers poses as outstanding potential for this application due to their accessibility and exceptional mechanical properties. And also the cellulose nanocrystal is a biodegradable polymer, which also the environmentally friendly fillers. So therefore, the CNCs have emerged as attractive additions in various sectors for sustainable and high performance materials. Next is the problem statement. So the first problem statement is the use of conventional acids such as hydrochloric acid and sulfuric acid in CNC production is giving adverse effects on the environment and also pose hazards to health and safety. So in order to solve this issue, in my research I will use the deep eutectic solvent (DES), which are low toxicity and safer compared to those conventional acids. And the second problem statement is the aggregation issues of CNC in PLA matrix due to poor compatibility between the two materials. So in this research, I will do modification on the CNC in order to increase the hydrophobicity so that the compatibility between the two materials will increase. The third problem statement is the challenge in determining the best condition for modified CNC loading, agitation speed, agitation time for making the nanocomposite of PLA and modified CNC, because without clear guidelines it's very difficult to consistently improve their physical, tensile, thermal, morphological, and water absorption properties. So this lack of standardization hampers the reliability and efficiency of the nanocomposite manufacturing process. So in this research I will alter and optimize those parameters and find the most optimum one for the fabrication of this PLA and CNC. And the fourth problem statement is the absence of detailed knowledge hinders the development of environmentally responsible materials and sustainable waste management strategies. So in this research I will do the biodegradability testing, which I will do the in natural weathering and also soil burial. So the objective for this research is first to assess the effect of CNC synthesizing parameters, which is the DS component, DS ratio, and hydrolyzing time, on several physical properties, which is the crystallinity, the morphology, and yield. Second objective is to analyze different effect of chemical oriented surface modification, which I will do three different type of modification, chemical modification, which is the esterification, phosphorylation, and silylation on the hydrophobicity improvement in CNCs. And third objective is to investigate the effect of fabricating parameters on physicochemical, tensile, thermal, morphological, and water absorption properties of the modified PLA and CNC nanocomposites using spin coating and extrusion method. And the last objective is to examine the biodegradability of the prepared PLA CNCs in natural weathering and soil burial environments. So here's a literature review about the previous study on biodegradable nanocomposites. Most of them use the same method, which is melt mixing, because melt mixing is the easiest and fast method. And here I only focus on few of the properties that I will study, but of course there's a lot of another properties that I will study in mechanical, physical, and also morphology. So for methodology in my research, so we'll start with the objective 1, to prepare and optimize the CNC using the DES. So it will be a different combination of DES, different ratio of DES, and different hydrolyzing time, in order to find one most optimum deep eutectic solvent. And then I will proceed with the best one of DES. I will proceed for the objective 2, which is the synthesis of modified CNC by analyzing the different effect of modification on hydrophobicity in CNC. So here also I will use the different type of chemical surface modification, which is the phosphorylation, esterification, and silylation, and I will compare between the three method to find the best one, and then I will characterize the modified CNC to determine the presence of the new group in CNCs, which the presence of the new group determine or confirm the successful modification method. After it is confirmed, I will go through to fabricate and optimize the PLA and modified CNC nanocomposite using spin coating method prior to the extrusion method or melt mixing, until the well-prepared sample is produced. After that, we'll go for characterization of the sample in physical, morphological, thermal, and mechanical, and then I will examine the biodegradability of the sample, and lastly the statistical analysis. So here is the testing and characterization that I will go through during my research. Here is the methodology, which only focus on the objective 1, which I'm doing right now. The flow is start with the DS preparation in terms of different combination, and then I will screening it to find only one best DS combination, to proceed with different ratio. And then the different ratio, I will only choose the best one ratio to proceed with the variation in time screening to find the most optimum time for CNC production. and then I will go for properties testing and analyze and conclusion. So far here is the preliminary result that I get. This one is the different DES components. Here is the chlorine chloride based DES. Here is only the appearance of the DES, which the good DES or successful DES is the one which formed a homogeneous and transparent mixture and also stable in room temperature. And here is the betaine based DES. Here is the picture of my sample. Next is the result of preparation of CNC. Here, this result, I already mixed it with the CNC in order to see or to investigate how can the DES be mixed with the MCC to get the CNC. So from based on the observation, it's fine that not all DES can mix with the MCC, only certain. So these 5 DES only can be mixed with MCC, and we'll proceed for the next step or the next subjective method. So far that's all for my research. Thank you.